Hello everybody, this is Dr. Andrew Chrysler. Let's continue our discussion on communication systems by looking at Chapter 3.2 in the Modern Digital and Analog Communication Systems and consider some topics presented in this textbook. In this video, I'm going to show you some useful functions and their transforms. So first, these are the functions that we are going to consider in this video: the rectangular function, the triangle function, and the sinc function. So the first is the rectangular function. We can call this the unit rectangular function. The unit rectangular function has a width of 1 and a height of 1, is represented by the uppercase pi symbol, and is defined as shown below. We call this the unit rectangular function when it has a height of 1 and a width of 1. However, this function can be generalized like this to a general rectangular function, which is defined this way. And the general rectangular function has slightly different. It has a width, which we're calling tau in our nomenclature. And so you can generalize this rectangular function to have any width tau, making these corresponding changes in your function definition. There's also the unit triangle function and the general triangle function. Again, we have defined these where the unit meaning, right, is indicating that the width of this function is 1, starting at -1 and going to 1/2. However, just like the rectangular function, we can generalize this using tau, where we have a general triangle function with a width of tau, and we've made some corresponding changes here where you'll see tau in our function definition. Now, one special function that you should be aware of is the sinc function. The sinc function looks like this, and we've given it this definition that's put in the box. This is an important definition to remember. The special function sinc has these 4 properties. The first is that this is an even function. It's symmetric across the y-axis. Second, sinc of x equals 0 except for when sine is equal to 0. When x, or when you have the argument of sine is 0. When x equals 0, then sinc of x is equal to 1. You can perform this proof using L'Hopital's rule. And this function is an oscillating and decreasing function. Also, there's one other special note, which is that there is another way of defining the sinc function that looks like this. Some textbooks use this method, and some online sources use this method. So if you're looking up information about the sinc function in this class, be sure to check your source. If your source defines the sinc function this way, you may end up with wrong answers, okay? So this is wrong for our class. So be sure that if you are using the sinc function, that you have it defined this way. Another thing to note about the sinc function, right, you can see that this function is oscillating and decreasing, and it crosses y equals 0, right? So y is equal to 0 here, and the function crosses over at multiples of pi. So it crosses over at 1 pi, 2 pi, 3 pi, etc., as it goes on to infinity. In addition to the functions discussed here, there's an entire table of transforms, right, where this is in the time domain, this is the frequency domain, and we have a transforms table like this. If you're in my class, you can access this table via Moodle. You can also look this up online. There are many such transform tables, and I hope that you will be able to find this information useful.